Yeah. Good evening, Sri Hari. Fine. So I hope you are able to see the screen and voice is audible to you. Small recap with what we were focusing yesterday. Um, yeah. In the yesterday class, we have started with different configurations of battery pack. So we were discussing for 4s2p, 8s4p. We understood what will be the battery pack voltage and what will be the battery pack age. 4s2p configuration, 8s2p configuration, and 15s4p configuration. And then
low battery, please charge.
What voltage rating of charger, what current rating of charger we need to buy for the given specification. Then our focus was to interface the battery, but we wanted to do, once we make the battery pack, it's very important that we need to sense the voltage of the battery, right? BMS will, there's no doubt at all. But how in a battery pack or in any electronic circuit, how do we measure voltage? Correct. So we started with some examples, and we understood that in most of the digital, all electronics today are digital circuits. Digital circuits means they have microcontroller inside, and microcontrollers are very low voltage device, in the sense that if you want to communicate with microcontroller, you have to communicate through voltage levels or voltage values. Voltage value should not exceed more than 3.3 or 5 volt in some microcontrollers. And suppose if the microcontroller gives you some output also, it can't give you more than 3.3 or 5 volt. That depends upon the controllers you select. But our intention was, okay, microcontroller to microcontroller pin, I can give only 3 volt, or microcontroller can accept only 3 volt or 3.3 or 5 volt. But how do I measure a 100 volt value? Assume I have a 100 volt battery pack voltage to be measured. Can I connect that 100 volt directly to the microcontroller pin? Of course, that is not possible, because the pin has limitation. So what we thought to design a small voltage sensing using a potential divider or voltage divider or resistive divider circuit. So we use 2 resistors in series to divide the voltage, and we choose the resistors in such a way that the maximum voltage after dividing should not exceed more than that of the division of the microcontroller pin, right? If the microcontroller accepts only 3.3, I have to choose resistors in such a way that the divided voltage should not exceed 3.3. So we did some examples of different ways of conceiving the circuit. So initially we have given a 10 volt input and 2 resistors in series, and we were trying to find out what is the divided voltage. And in the second case, we have seen the divided voltage is given, but to get that divided voltage, what resistor value we have to choose. So that is the second exercise what we have done. In the third exercise, if 2 resistor values are given and the divided voltage is, then we were asked to find what will be the total voltage applied to that circuit, that is Vs. And the formula we used was Vx equal to V2 divided by R1 plus R2. Vx voltage which goes to the microcontroller pin. Vs is the actual voltage coming into the circuit. It could be any power supply. It could be from your battery voltage which is to be measured. Then we did a couple of other case studies also. You can see here. Pratik, I'll tell you at the end of the class. Okay, please. And see here, we were finding in all the 8 cases, we were trying to find the battery voltage if Vx voltage is measured, right? So for example, this Vx voltage is given to the microcontroller pin, and microcontroller pin is giving you 0 volt. If you read 0 volt, then what will be the actual volt? So we have seen different cases. First case, and if the sensed voltage is 0.5, what will be the VB? With the sense, what will be the VB, and so on, right? So we have done 8 cases. Is there any? And then finally we were concluding that, okay, I understood what value of resistors I designed for the sensing, but what of resistors should I select? Because of the same value of resistors, same value, let's say 1K or 2.6K, whatever it is, we may have different sizes. How do I understand which size I have to buy? Size in the sense that depends upon the power rating of the resistor. So starting from 1/8 watts in the market, 1/8 watts means into 125 watts means that the resistor is able to dissipate maximum 0.125 watts, right? So we have 0.25 watts, 0.5 watts, 1 watt, 2 watt, 5 watt, 10 watt, 25 watt, and so on. So out of these sizes, which size I have to prefer? So that we have understood by, we were calculating the current flowing through the resistor. Then we found out I square R, which is the power dissipation on the resistor. And after calculating the power dissipation, we found out what is the wattage needed for that, or what is actual power dissipation in terms of watt. So we have taken one case here. 5 volt is the input, and resistor is 1K, and we have an LED connected to the circuit. And through the data sheet, we have seen the LED needs 0.02 amps. Since the resistor and the LED are in series, the same current, 0.02 amps current, flows through resistor. So current flowing through the resistor is I, which is equal to 0.02 amps in this case, and the resistor value is 1K. So we calculated power dissipation, which is equal to I square into R. Right? So I square R, the answer was 0.4 watts. Means that in this circuit, I have to choose the actual dissipation of the resistor is 0.4 watts. So that means you cannot choose any resistor of the same value below 0.4 watts. That means you cannot choose 1 by 8 watts. Because 1 by 8 watts can dissipate only 0.125 watts. But your requirement is 0.4 watts. The resistor is a dissipating circuit. So you cannot choose 1 by 8 watt size. You cannot choose 1 by 4 watts. But you can go for 1 by 2 watts. 1 by 2 watts means 0.5 watt. Means that be able to dissipate up to 0.5 watts. It can handle up to 0.5 watts. But your requirement is only 0.4 watts. So it's better to choose 1K half watt resistor in this case. Yeah, circuit we done it yesterday, sir, and LED, and LEDs and resistors are connected in series. And the data sheet, we understood that the LED needs 0.02 amps. So when two elements are connected series, element will get amps. Question is that what is the across the resistor? How much power will be dissipated across the resistor? So the formula is power dissipation is equal to I square into R, right? So what is I? I is this current, the current which is flowing through the resistor, 0.02. Okay, so 0.02 square into R. R is nothing but the resistor value, which is 1K. So 0.02 the whole square into 1K, which is 0.4 watts. That means for this current, okay, and this value of resistor, the resistor is going to dissipate, okay, 0.4 watts of power or heat equivalent to 0.4 watts. So that means I need to select a resistor which can handle more than this. So I cannot go for 1 by 8 watts. This is not possible because 1 by 8 means 0.125. 0.125 is lesser than 0.4. I cannot go for 1 by 4 because 1 by 4 is 0.25. That is also not possible. And I can go for 0.5 watts because 0.5 watts is greater than 0.4 because actual dissipation is 0.4 watts. So, but I can choose 0.5 watts. It can withstand with that heat. So in this example, you will be preferring to choose 1K 0.5 watts resistor for the circuit. So this is how we calculate the size of the resistor while doing the sensing. Okay, fine. So this is what we have done yesterday. So now I'll show you a small demo on how to measure the voltage using a microcontroller. And I have chosen a microcontroller which is called PIC microcontroller, PIC, Peripheral Interface Controller, which is from Microchip company. Let me just run through the program which I have written for you. The objective is not to teach you the program. The objective is to show you that how high voltage, let's say 14.8 volt, is measured by the microcontroller using the potential divider circuit which we have designed yesterday. That is the focus. The focus is not to teach the program. Idea, this program written for showing the demo. Okay. So as I said, the objective is not to teach the program. So don't worry about the program. But let us focus on these two lines. Okay. So in these two lines, what I have done, in the first line, this measures Vx. Okay. Will 5 volt. So this 50 means 5.0. 5.0 is what I have shown it as 50. Okay, don't get confused. It is nothing but 5 volt. 5. Okay, and this one, after knowing Vx. So let's say this is our circuit. Okay, so our battery is available. Okay, so this is my battery. So this battery is going from 0 and we can go up to 14.8 volts. Okay, 0 to 14.8. I hope you remember why this is 0 to 14.8, which we discussed yesterday itself. And we have two resistors, R1, R2. Okay, R1. Now in the yesterday's example, I have told you that this one Vx, we did it for 3 volt. Okay. Now in this particular example, I'm making this Vx to be microcontroller pin is 5 volt because peak microcontroller can accept up to 5 volt. So that means when 14.8 volt is the input, suppose the battery reaches 14.8, I should 5 volt here. Okay. So this circuit I can redraw like this. 14.8. When the battery voltage is 14.8, I have to choose the resistors R1 and R2. Okay. R1 and R2 in such a way that this Vx can be 5 volt. Okay. You understood? So when this is going to be the maximum, right? This is going to be the maximum. So when this is 14.8, or if you are getting confused, we can make it as 15. Suppose 14.8 is confusing you, you can tell that, okay, if this is 15, if suppose the input is 15 volt, my Vx is 5 volt. Okay, and this 15 volt, it is not going to. We have discussed only for 14.8, and we are not allowing it to go above 14.8. Okay, so you can assume this is 14.8 or 15, not an issue. 15 I put why? Because 15 and 5 you can divide it is very okay. So the intention right now is assumed from 0 to 15 volt, 0 to 15 volt, and maximum voltage coming to this battery is only 15 volt. Okay, and what is the maximum voltage which can accepted by the microcontroller pin? It is 5 volt, right? So when 15 volt comes, I want 5 volt at the input microcontroller pin. If so, what will be my R1 and what will be my R2? Okay, so I have chosen R1 is 4K, okay, and R2 is 2K. Okay, now you can just try this. You can try this. We know the formula Vx is equal to Vs. This is Vs or Vb. You can call it as Vb. Vb R2 divided by R1 plus R2. So what is Vb? Vb is 15. So 15 into R2. R2 is 2K, and R1 plus R2 is 4K plus 2K. So what will be the answer? 15 into 2 divided by 6. So 30 by 6 is 5. Okay. So I have chosen 4K and 2K, or you can choose 8K and 4K also. Not an issue. Okay. You can choose 8K and 4K, or you can choose 10K and 5K. Not an issue. But ensure that you have to choose in kilo ohms, which we have discussed yesterday. So I'll repeat. I have a voltage maximum is 15 volt. When battery voltage is 15 volt, my analog or the microcontroller pin input should be 5 volt. When VB is 0 volt, this will be 0 volt, correct? This will be 0 volt. When VB is 7.5 volt, correct? So this is how the division. But if is it okay, everyone? Is assume we will do BMS, but when you we are our focus is to interface the battery pack with. But what how BMS does all that also like, okay, later I'll show you a ready-made BMS so that you'll be able to relate how BMS is doing that particular sensing. Okay, is it clear? Okay, so I'll quickly move into the program. So okay, voice stuck. One second. Am I audible now? Okay. Fine. So, is it okay, sir? Anyone? Any problem with this explanation? It's the same story, what we have done yesterday. We have done it for 3 volt, but today I am talking about 5 volt. That's it. Okay. Right. So, if you look at in this program, what I have done, this particular line, I am going to measure X. Okay, Vx. Is that by knowing this Vx voltage, we are going to find what is Vb, right? So the intention is to measure the sensor voltage, correct? But we cannot measure it directly because the pin can accept only up to 5 volts. So that's the reason we are dividing it. So this is the divided voltage. Okay. So once you know divided voltage, assume the divided voltage is 5 volt. Okay. If the divided voltage is 5 volt, how do you find Vb? If Vx is known, okay, if Vx is 5 volt, okay, R1 is 4K, R2 is 2K, how do you find Vb? Vb equal to Vx into, you can cross multiply this, Vx into R1 plus R2 divided by R2, correct? So this becomes Vx is 5 into R1 plus R2, which is 6K, divided by 2K, correct? So it is 30 by 2, which is 15 volts. So this is how we measure the high voltage. So that means we don't measure high voltage directly. We measure the divided voltage and calculate the high voltage. You understood? We never measure the high voltage. We measure the divided voltage and then we calculate or manipulate the higher voltage. So here in this case, I don't know what is the value of VB, but I can know what is the value of Vx. Right? So by knowing Vx, I can use the formula to find VB. So in the program, you can see in this line, I'm finding Vx. So if Vx is known, here I am finding Vb. Okay, here I am finding Vb. How did I find Vb? Vb equal to Vx into 6 divided by 2. Okay, so Vx I measure it directly. To find the Vb, right? So this is how I have done. I just compile the code and try to build it. I just designed a circuit. The code, you can see the time is 7:27 now, 28:12. So let us keep the battery voltage is 10.2. Okay, so the battery voltage is 10.2. Now on the screen you should get 10.2 or close to that. Okay, so now you can see it is 10.2. The value is 10.2. Let me try to put another value, say 14 volts. Okay. And you can see around 13.8. Some a little bit of tuning is needed in the formula, but it is showing 13.8. Okay, so this is VB, but you can see Vx. Vx is what? This voltage, 4.66, right? So 4.66 and by 2. That is what this value, VB. Okay, so hope you understand. Yes. Okay. Try to zoom it. So here you can see this is the battery. Okay, this is the battery. This one is the battery, and this one is the potential divider, 4K and 2K. And this voltage, this point, okay, this point is what the divided voltage, and this should not exceed 5 volt. Okay, so here you can see when the input is 14, this is 4.6659. Let's say if the input is 15, how much you should get for this value of resistor? If the input is 15, what should be Vx? Should be Vx? 5 volt, correct? So you can see here 4.9999, right? So it is 5 volt. Okay, so basically this voltage is what you can see here. This wire is actually going to the microconductor. Let me try to show you. You can see here this microconductor. Okay, this goes to the microconductor, and we measure that Vx, but through formula we calculate and display the 15 volt. Okay, on the screen. So on the screen you can see right now it is 15 volt. So beyond that, if I increase, let's say above 15, if I increase, let's say 15, I'm putting it as 20. Okay, and you can see the Vx. Okay, the Vx will be 6.66. Okay, the Vx will be 6.6. But you can see here, this is not changing. Why this is not changing? Because the microcontroller pin cannot accept more than 5 volt. And this thing which we have to avoid, since it will get damaged very easily. Okay, but in simulation it works, but in practical we shouldn't give. That although I give 20, you cannot see 20 on the display because the microcontroller pin cannot measure more than 5 volt. Here you can see the divided voltage is 6.6 volt, which it cannot understand. So that's why the value is getting saturated at 15 volt. Okay. So are you able to understand? Are you able to observe the result? So the point over is that if you take a BMS where you give 24 volt or you may give 100 volt or 300 volt, whatever it is, the BMS microcontroller inside the BMS is not going to measure that high voltage directly. There will be a potential divider, and that divided voltage will go and measure by the microcontroller. By knowing the divided voltage and knowing the resistor values, we calculate the high voltage. Okay, so that's how all the voltage sensing happens in the electronic circuits. Fine. Right. So I hope you understood how voltage sensing happens. Now let's go into the next topic. The next feature what the BMS does is temperature sensing. Now let us understand how the temperature is sensed. Temperature sensing. Two ways we can do. One is we can use. What is the question? Microcontroller gives signal to battery to control charging. Yeah, microcontroller will give you digital output signal. high or low signal, or PWM signal, analog output signal. Okay. Temperature sensing we can do in two ways. One is using resistors, but these resistors are normal resistors, not normal resistors. They are thermal resistors. Thermal resistors. Thermal resistors.